do these problems. You've written it on the back of 8.1 notes. So, the difference between this problem and all the previous problems is that we have two terms, right? So, there's one extra step that you have to do, but everything else will be the same. We're still going to cross multiply, but 2 is being multiplied by that entire denominator, a and minus 3. So that's going to look like distributive, right? So you don't have to write it like this. You could do it in your head and write it down if you want. I'm going to write it down just so we all know we had to distribute to a and the negative 3. We cross multiply the other way the same way. 10 times 4 is still 40. We're going to distribute. We got 2a minus 6. Add 6. So if 2a equals 46, then what does a equal? 23. Perfect. All right, the second, we'll do the same thing. Do you want to do 9 first or 8 first? Doesn't really matter, I should know. 8 sounds good. So we're going to multiply 8 times k plus 6, and then multiply the other direction. 9 times 6, which is 54. So we have 8k plus 48. Just a warning, this is not going to be a pretty answer. Equals 54. Subtract 48 on both sides. What is 54 minus 48? It's 6. Yep. And then divide by 8. And that means k equals 3/4. Good. And then the last one, again, we cross multiply. So 4 times n minus 9, and it will equal 7 times n plus 5. Distribute. So we have 4n minus 36 equals 7n plus 35. Subtract the smaller n. So minus 4n, minus 36 equals 3n plus 35. What's my next step? Subtract 35. This one is going to be even uglier than the first one, or the second one. What is minus 36 and minus 35? Negative 71, and then divide by 3. Does 3 go into 71? It does not. So negative 71 over 3 it is. But I wrote the formulas at the top to remind you. For perimeter, we take a side from the first over side from the second, and it is equal to the perimeter of the first over the perimeter of the second. Area is the same. What is the only difference in the formula? Squared. The sides are squared. So in these two, we're given parts of the formula and have to find one of the sides. So in this first one, am I going to use perimeter or area? Perimeter, how do I know? It says the word, right? So side 1 over side 2, this is the abbreviated version, equals the perimeter of the first over the perimeter of the second. So we're just going to read figure A. We can call it the first one if you want. Has a perimeter of 60 inches. So where am I going to put the number 60? Yeah, for P1. And then the side length is 5. So that will go for side 1. And then figure B has a perimeter of 8 inches. So that's going to go for P2. So we don't know the other side for the figure B. I put X, some of you put S, that's totally fine. And then once we have one fraction set equal to another, we cross multiply. So we have 60x and then a large number. What is 5 times 84? 420, not too bad. Divide by 60, and that missing side length is 7 inches. Perfect. So again, you're going to have one of those on the test. You will also have one of the next one, which is harder because it's area, and we'll talk about that. So side 1 over side 2 squared equals the area from the first over the area of the second. So figure A has an area of 4,928. 4,928. And one of the side lengths is 88 feet. Figure B has an area of 77 square feet. We're going to find the missing side length. So before we begin, we will get large numbers if we leave it like this. I always like to see if this can be reduced. So let's look at the bottom because it's a weird number. It's 77. You can just flat out see if 77 goes into this. It does. Or you could see, what are the factors of 77? What are the two numbers that when you multiply them, they make 77? Yeah, 11 and 7. So you could also try dividing them by that. But I know that 77 goes into 4,928. How many times does it go in? 64. So here's what I recommend. We want to keep this a proportion to keep our life easy. So even though this becomes 64, just 64, I would keep it over 1, bless you, so that we still have a fraction equal to a fraction, a proportion. The other fraction, when you square a fraction, you square the top and you square the bottom. So what is 88 squared? Good. 7,744. And then when you square x squared, it's just x squared. Okay, so this is what it looks like right now. We're going to cross multiply like normal. So x squared times 64 is 64x squared. And then 7,744 times 1 is, 7,744. All right, so if this squared wasn't here, what would your next step be? Divide by 64. It's still your next step. It doesn't matter that there's a square there. We need to get the square alone before we can deal with that. So divide each side by 64 like normal. And x squared equals 121. So if x squared equals 121, we want to get rid of the squared. We have to do the opposite. So what's the opposite of squaring? Square rooting. So we're going to do the square root on both sides. This cancels out the square. So what is the square root of 121? 11. And it would be feet. Perfect. So that's the end of 8.1. We move on to 8.2 and 8.3. They're pretty simple, which is why we're learning them today. There are 3 theorems that prove triangles are similar. You don't need to know all of the things, because what makes shapes similar? What's proportional? The sides are proportional. Sides are proportional. I'm just going to write prop. And then what else makes shapes similar? The angles are the same measure, right? The angles are congruent. You don't have to know all of that to figure out that triangles are similar or not. There are 3 theorems, and if you remember when we did like a whole chapter on this for congruent, it's very similar. So there are 3 theorems. I'll give you like a rundown of each of them. The first one's called angle-angle. So you remember how all of the angles need to be congruent? Well, one of the theorems says if 2 angles are congruent to 2 angles, that is enough to prove the triangles are similar. So that's the first one. The second one is side, side, side. What do the sides have to be for similar shapes? The sides have to be proportional. So if all the sides are proportional, then the triangles are similar. That's enough to prove the triangles are similar. You don't have to know anything about the angles. And then the last is called side, angle, side. Again, what do the sides have to be? Proportional, and the angles have to be congruent. So if you have two proportional sides and an angle in between that's congruent to an angle between you, that's enough to prove triangles are similar. So there's 3 of them. They're not super complicated, especially angle, angle, which is the first one we're going to do. All we're looking for is 2 angles congruent to 2 angles. And if we have that, then we have angle, angle. Triangles are similar. All right, that is the first one. This is just review. Similar figures have the same shape. They're proportional in size. They have congruent angles and proportional sides, just like we talked about. These 2 triangles are similar. One is just larger than the other. So one of the theorems, like I was saying, was angle, angle. You just need 2 angles congruent to 2 angles, and that is enough to prove triangles are congruent. That's it. So I'll get through that. Example 1. We wanted to figure out if these 2 triangles are similar. If they are, write a similarity statement, and then we'll explain our reasoning with either angle-angle theorem or it wasn't angle-angle theorem. So let's look at this. We have in our first triangle 26 degrees and 90 degrees. So what does this remaining angle have to be? It is 64. Look at the second triangle. We have 90 and 64 degrees. Well, actually, we don't even have to do that. Do we have 2 angles congruent to 2 angles now? We do. We have a 90 and a 90, a 64 and a 64. So are these 2 triangles similar? Yes. So if they are, so yes, they're similar. We're just reading the question. Determine whether they're similar, yes. If they are, write a similarity statement that says that triangle blah blah is similar to triangle blah blah. So what do we want to name the first triangle? CDE is similar to triangle. If I said C first, what letter would go first? K, because that one will be the 26 degree. And then I said D second, so that is G and then H. And then last it says explain your reasoning. We knew this because of angle-angle theorem. That's it. And then we're just going to practice it. Boop. Determine whether the triangles are similar. If they are, write a similarity statement. And explain your reasoning. All right, so we only have 2 of the angles. They don't match at the moment. We have 21, 99. We have 61 and 21. What is the measure of angle Y going to be? Is it? 21 and 99. It's 60? Okay. So are there 2 angles congruent to 2 angles? They're not. All right. So are they similar? No. Explain your reasoning. The angles aren't congruent. Something to that effect. This is when it gets harder it says show. When you see show, this is similar to the prove. All right. So if you are going to prove that they're similar, you essentially want to prove the theorem. So in this case, we're trying to prove the angle-angle theorem. So if you just want to write it like this, we want to show that 2 angles are congruent to 2 angles. This first one, you have to kind of think outside of the box. We're comparing ABE to triangle ACD, which is the outer triangle. So automatically, we have 52 degrees and 52 degrees, right, in both triangles. So we're going to name those as congruent. Can I call this angle, can I call it angle B? I cannot. There's 2 angles here. So we need to use 3 letters. So what will we call that angle? ABE, that sounds good. Angle ABE, I'll outline it to show you. So we said ABE, you could have also said EBA, it's the same thing. And it is congruent to this angle down here. Can I call it angle C? Yes, I can. There's no other angle at that vertex. So that's my first angle. There is another one. You have to think probably think about it. So there are only 3 angles in this blue triangle, right? There's no proof that E is congruent to D. There's just none. Does everyone see A? And how A is an angle in both triangles? They overlap at A. Everyone sees that? So if I were to take them apart, angle A would be the same measure as angle A. So we're going to list that one as well. This one is congruent to itself because they both share that angle. So angle A is congruent to angle A. It's similar to the sharing the wall thing. They're sharing that angle. So that's enough to show that the 2 triangles are similar. We have a question about this one. I think it'll show you it's separate. Some people find it helpful to redraw them. Personally, I do not, but it just is what it is. I repasted my answer. It's just going to be ugly, but there it is. This second one, what do we know that we know that we know is congruent in this picture? It's not marked, but we know it. We know vertical angles are congruent. They're still congruent. They're not going to be marked, but we know that they're congruent. The second set of angles is harder to see, but what is the only other information we're given in these 2 triangles? The sides are parallel. So remember that when you have 2 lines that are parallel and a line that is touching both of them, you want to be thinking about the relationships of a transversal. And in particular, an alternate interior angle. So I'll show you. Here are the 2 parallel lines. There are 2 lines touching both of them. So you could just pick one of them. SU is touching both of them. So this creates alternate interior angles inside of the parallel lines on the opposite sides of that transversal. So we could name those 2 angles, or even RT is a transversal, and it creates these 2 angles. So it doesn't really matter which one you want to do. But either way, we're trying to name 2 sets of angles and go from there. We could start with the vertical ones and then decide which transversal we want to use. Can I name these angles angle V? I cannot. So what can I name this angle on the left? RVS sounds good. Angle RVS is congruent to, it does matter the order. So you see how R corresponds with T? So we're going to say TVU. Angle TVU. All right, and then last, the alternate interior angles. Do you want to use SU as the transversal or RT? SU sounds good. So then that means these 2 angles are congruent because they're alternate interior. Do I need 1 letter or 3 letters to name them? Or can I have 1 letter? I could just have 1. So I could say angle S is congruent to angle U. And that's angle, angle. So anytime, if you want to highlight, you see the word show, that's what you're looking for. So that's the first theorem. 2 angles congruent to 2 angles. The next 2 are in the same section, so if you want to turn. Side, 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 and side, angle, side. So side, side, side is really, really simple. If all 3 sides are proportional, then you have similar triangles. So you're going to set up a proportion like this with their lengths. This is actually the section and the reason you have 2 to 3 highlighters out, because it's in black and white, it's a little harder to see. In this first question, we are deciding if either DEF or GHJ is similar to ABC. So one of these 2 triangles is similar to this one. One of them is. So I'm going to draw like a line so you know we're comparing these triangles to ABC. And we're going to use our highlighters to figure out what corresponds with what side. So here's what that looks like. I'm going to start with AB. What does AB correspond with on the first triangle? DE. So I would highlight that side. This helps you figure out which sides you'll write a proportion with. And then what about with HGJ? What does AB correspond with? GH. So that's my first color. I used one color for the corresponding sides. I'll pick a second color and do BC. What will BC correspond with in this first triangle? EF and HJ. This is why you definitely should have two. If you have a third, I'm going to highlight them. You don't have to technically, but the remaining ones all correspond with each other. All right, so we're just going to figure out if the sides are proportional to each other. We do that using the scale factor. When you do the scale factor, which number goes on the top? The new length, and then the old goes on the bottom. So let's first compare these two. Remember, we're always comparing back to ABC. We're trying to figure out if DEF or GHJ is similar to ABC. So that means if they are similar, ABC turned into DEF somehow. So what is the new length? I'll do the green ones first, AB. What does AB correspond with on the second triangle? DE, which is 6. So the new length is 6. The old length was 8. What does this reduce to? 3/4. We're going to see if all of these scale factors are the same. It doesn't really matter if we go to BC or AC. Which one would you like to do? BC. So BC was multiplied, hopefully, by a scale factor to get 9. So what is my new length? 9. My old length? 12. What does that reduce to? 3/4. It's looking good so far. But keep in mind, it's called side, side, side. So all the sides have to be similar and have to have the same scale factor. All right, so then we'll do the last set. 16 became 12. What is the new length? 12, and the old length is 16. What does that reduce to? 3/4. So are those sides proportional to each other? Yes. So we're going to say triangle DEF is similar to triangle ABC. That's actually the answer. We don't have to do anything with the next triangle because it says is either or. So it was one or the other, and we just kind of eliminated one of them. Is there a question on this one? Okay. We will do it again. There we go. So yours looks a little different than mine. This is the triangle we're comparing to. It's above. Does everyone see it? It's called ABC. So same idea. These are two separate questions. We're figuring out if RST is similar to ABC. So we're going to go through and highlight again. I'm going to start with AB, which corresponds with RS. BC corresponds with ST. And then last is AC, corresponding to RT. I'm doing them one at a time, so I'm ignoring the second one for now. I just want to figure out if the first one is similar to ABC. So we're going to do the same thing. So this one, ABC is the old, if you will. So we're trying to see if ABC became RST. Okay, so we'll call this the new. Ooh. All right, so I'm already in purple, so I'm going to pick BA and SR to go with first. Which of them is the new length? 8, and the old length is 6. Do you see how we have a decimal right here? Which means a decimal is going to be in a fraction. So we're going to end up making these into decimals just to actually figure out if they're similar or not. What is 8 over 6 as a decimal? It's 4 over 3, which is 1.3. It's like 1.3 repeating. You can reduce it and then divide it. You're going to get the same answer, 1.3. Which sides do you want to do next? Which one? 7 and 5, sounds good. So we're doing BC and ST. Which one is the new length? 7, the old length 5. What is this reduced to? We'll make it a decimal again. 1.4. All right, so automatically, are they similar? They are not. So we're just going to say not similar. If you want, you could always write this statement and then put a slash through it. That's also fine. But they are not similar. All right, I'm going to, some of you already did this, but I did not. SR corresponds with AB. RT still corresponds with AC. And then ST corresponds with BC. So we're using the same ABC. And figuring out if this triangle is similar to the ABC triangle. So, again, it's the same triangle, so we had a decimal. I would make these into decimals, but also 12 over 5 would be put into a fraction, and it's complicated. So we can make these into decimals also. Do you want to start with the ugly one first? Sure. So 12 over 5 is the new length. What is that as a decimal, though? 2.4? So 2.4 is the new length over the old length, which is 6. So again, we're going to turn this into a decimal. What does it make? 0.4. Which sides would you like to do next? We have BC and AC. Which one? BC, sounds good. So BC is 5. It corresponds with 2. The new length is 2. Old length is 5. This definitely makes 0.4. Things are looking good. And then last, we have 2.5 and we have 1. What is the new length? 1 over 2.5, which makes 0.4. So these are similar. We're going to say triangle RST is similar to triangle ABC. I'm just going to remind you some things. You see how 2.4, 2, and 1 all came from the same triangle? And then the same thing with the denominators. 6, 5, and 2.5 came from the same triangle. It has to be like that every single time, okay? Or it won't be proportional. When you're ready, there's one more from this section, and then we move on. Find the value of x that makes ABC similar to DEF. What do we know about similar sides? They're proportional. Are they equal? They're not. So we're not setting things equal. We're going to set up a proportion. So if you notice, we have two x's in two different places. I'm going to tell you, to make your life simple, you will pick one and deal with the one. X in both of these represent the same number. So technically you get the same answer as long as you set things up correctly. I usually pick the least complicated one. Which one is less complicated? X minus 1. So that's the one we're going to work with, that x minus 1. So remember that similar sides are proportional. We're going to set up a proportion. So I'm going to write it with letters first to remind you. What does BC correspond with on the second triangle? EF. And we can make it proportional to another two set of sides. So you have two options, but which one would we rather use because it's corresponding with the less complicated? We want to use AB because AB corresponds with DE. So again, my numerators come from the same triangle. My denominators come from the same triangle. We are good to go. So now we just plug in. What's the length of BC? X minus 1. The length of EF? 18. It is equal. What is the length of AB? AB? 4. And the length of DE? 12. So now we just have a proportion like we were solving at the beginning. We just cross multiply. Just make sure you distribute 12 times both x and -1. And then what is 18 times 4? It is 72. So we have 12x minus 4. Then what do we do? Add 12. What is 72 plus 12? 84. So then x is 7. So for side angle side, we need two sides, proportional, and then the angle included is congruent. So you could read it, or we could just look at the picture. We're comparing these two triangles and seeing if they are similar. Is the angle in between the two lengths given, are they congruent? Yes. So if side angle side, we got the angle in the middle. It's 53. I know it's hard to see it on my board, but you can see it on your paper. So now what we need to figure out is if the sides are proportional. And then if they are, then we have side angle side. These triangles are similar. All right, so let's start with 6. What does 6 correspond with on the other triangle? 9. So we could see if they are proportional. I'm still going to put the new over the old just to keep with the habit. So what is the new length? It's what? It's 9. And then the old length is 6. This reduces to 3/2. We want to see if that is the same proportion as 10 and 15. What is the new length of 10 and 15? 15, and the old length is 10. What does that reduce to? 3/2. So are the sides proportional? Yes. So then we have side angle side. So we're going to say they're similar. So triangle FGH is similar to triangle ABC. And it's because of side angle side. How do we feel about it? Good. All right, the bottom, show, it says show again. So show, anytime you see that, you want to, last time we would put AA because we were proving angle. We're proving side angle side this time. The only thing that will be new to you is the sides aren't congruent, they're proportional, so we have to write it that way. So we can start with, and actually, we don't even need the second S. Here's why. We're going to show that the sides are proportional. So SR and PN correspond with each other, right? Or we don't have to use the numbers. We could just write the statement of proportionality, which is with the letters. So what is the new length? It's 18, it's PN. So we're going to put PN over the old, which is SR. And it is it's proportional to the other set of sides. So what would I put in the numerator there? NQ over RT. So this shows that two sides are proportional to each other, all in one. Are we okay with it? Okay. And the last thing is the angles. We want the angles to be congruent, so angle R is congruent to angle N. That's it. We do it one more time. So we're going to prove the sides are proportional. We actually don't need all the sides. For side angle side, we only need two of them. All right, so what are the two lengths in this first triangle that would prove side angle side? Only two of them would include the angle that's congruent. It is 12 and 16. So 12 and 16. Because here's a right angle. The angle next door will be the right angle. Side angle side, the angle has to be in between the two sides. It has to be touching both sides. So the 20 is just there. It just is. So we're going to list. Oh, sorry. We'll start with what WZ. What is WZ proportional to? YZ. So we would say YZ over WZ is proportional. This next one is weird. To XZ over XZ. And then the angle, we just list the two right angles. Can I call them angle Z? I cannot. So what can I name? We'll say the left one. Correct. Angle WZX is congruent to, so we said WZX. We would say it's congruent to angle YZX. Good. At that point, you've learned it all. I think on the back, it just summarizes all of them. And we'll write down what summary is. So for angle-angle theorem, what do we have to have? Two congruent angles. You could shorten that if you want. That is the first blank. Two congruent angles. For side, 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 what are you looking for? The sides are proportional. You could just write all sides proportional or however you want to do it. And then last, for side, angle, side, the two sides will be proportional and the angle included will be congruent.